simultaneous equations. The below picture shows the graphs of two lines. One line has equation y equals 8 minus 2x, and explain with reference to the gradient and y-intercept why the other line has equation y equals 2x minus 4. So the first thing we have to figure out is, okay, which line's which? Y equals 8 minus 2x. Now, what do we know about y equals mx plus c? Okay, so the m here is minus 2. So the gradient of this line is minus 2. That means it's downhill, remember? And the y-intercept is 8. So this is the y equals 8 minus 2x. There's the y-intercept 8. How do we know the gradient is 2? The gradient is minus 2. Every time we go across one, we go down minus 2. And across one, we go down minus 2. Across one, we go down minus 2. So the gradient there is minus 2. Explain with reference to the gradient and y-intercept why the other line is y equals 2x plus 4. Okay, why is it 2x? That's 2x minus 4. Why is it 2x? The gradient is 2 because every time we go across one, we go up 2. Cross 1, up 2. Cross 1, up 2. So the gradient is 2. And the y-intercept there is minus 4. So if you look at that, all straight lines can be written in the form y equals mx plus c, where c is the y-intercept and m is the gradient. The line crosses the y-intercept axis at minus 4, therefore c equals minus 4. And the rise over run, or the gradient, if you look at this triangle here, maybe, it rises 4 every time it goes across 1. So 4 over 2. 4 over 2 is 2. Therefore, the gradient is 2. Find the exact point of intersection. So how are we going to find the exact point of intersection? Now, we could read it off. It looks like x equals 3 and y equals 2 here. This is the point of intersection, maybe the break-even point, if this was an economics question. But this is probably x equals 3, y equals 2. They have said the exact point, so let's solve them simultaneously. The nice thing about solving these simultaneously is that this is what y equals, and this is what y equals. So what we're saying is, when are the y's exactly the same? So that's all I've done down here. I've just set it up. We know that this equals y and this equals y. So I've just put them together, and then I can get rid of the y's. So if I get rid of the y's, because they both equal y, it's like John is the same as Steve and Steve is the same as Michael, so John is the same as Michael. It's that sort of logic. This equals that and y equals that, then these two outside ones must be equal as well. And how are we going to do this? We've got a minus 2 on x on this side, so we're going to add 2x to both sides, so it's going to make it 4x here. And then would it be nice to move this minus 4? What's the opposite of minus in 4? Plus in 4. So minus 4 plus 4 on this side becomes 0. Plus 4 on that side becomes 12. 4x equals 12, therefore x equals 3. When x equals 3, we know that y equals 2 because we can put it into this one if we want. When x equals 3, 2 times 3 is 6, minus 4 is 2. What would happen if we put it into the other one, I wonder? Would we get y equals 2 as well? That's the whole point. We should. So 8 minus 2 times 3, if x is 3, what's 8 minus 2 times 3 is 6. 8 minus 6 is 2. Yep, perfect. Thanks.